Welcome in our today's mathematics lesson, where we are continuing with the fractions and decimals. And today we are going to look at multiplying and dividing decimals by 10, 100, 1000, and so on. Now, earlier on, we looked at the fractions and we realized that you can simply multiply fractions. Now I want us to look at the decimals and see, is it also possible for us to multiply decimals? In our daily lives, we find decimals are frequently used. For example, you can find somebody going to buy maybe fuel, and when you're buying fuel from the gas station, it can cost you maybe, let's say, $2.58. So if you buy 10 liters, you will multiply by 10. So multiplication of decimals has been there, and it's always there for use in our daily lives. But I want us to consider this. As we multiply, we must always know that the place values of the digits are maintained. Always we must maintain the place values. Take, for example, if we have a number like 2.58. This number 2.58, as you can see, is simply a number, but when you place it in a place value table, then you realize that you are able to know that 2 is for the units, and then we have 5 for the tenths and 8 for the hundredth. So in this particular case here, we shall have to maintain that because of the table here, we need to know where each one lies. We have our decimal point here. This is the decimal point. Now, from the decimal point, you'll realize that what we have here is the units. And units here for this particular case is 2. After the decimal point, what follows here is the tenths. And at the tenths, we have 5, and then a hundredths, where we have 8. So we should be able to always know the place values of decimals any time we are working on them. Now, in multiplication, you don't need to operate it like any other, but we shall just do the operation the way we are used to while operating whole numbers. But the only difference is how it will behave when we are now looking at the decimal places. Now, I want us to start by looking at simple. When we are multiplying by the multiples of 10, like 10, 100, 1000, and so on. So we shall use the table here to illustrate this and to show what we require. In our table here, we have the operation. And then we have the visualization. And then we have the example. Now, here you find that the operation, for example, is, let us take, for example, multiplying a decimal by 1000, which is the same as 10 to the power of 1 of 3. So our visualization here we find that the decimal point, find that the decimal point moves 3 places to the right. Decimal point moves 3 places to the right. Now we want to illustrate the example there. Take for example 23.758 multiplied by 10 to the power of 3, which is equivalent to 1000. So as you can see, 10 to the power of 3 is 1000. And if that is the case, a decimal point moves 3 places to the right. 3 places to the right. So for this particular case here, we are going to have our decimal point moving 1, 2, 3. That is where it will stop. So our new digit, which is our answer, will be 23,758. That one will be our answer. Second, let us see, multiplying a decimal by 100. By 100, and 100 is the same as 10 to the power of 3, of 2. Now in this case, when multiplying the decimal point, the decimal point here will move, because the power of 2, it will move 2 places. It moves 2 places to the right. It will move 2 places to the right. Now, we shall just use the same number to illustrate. What happens when we multiply the digits, the number 23.758 multiplied by 10 by 100? So it is said the decimal point will move to the right 2 places. So when you look at 2 places, the first place is at between 7, the second place is here. So you'll have 2375.8. So you find that it changes, the value changes, and we have moved 2 places. So we stop there, and that is what we have. So when we are multiplying, as long as it is 10 to the power of a number, if it is only 10 to the power of 1, it moves 1 place. If it is 10 to the power of 4, then the decimal point will move 4 places to the right. But when we are dividing now, the opposite occurs. I want us to look at it when we are dividing, because we can't continue this, because anytime we are multiplying by the power of 2, power of 3, 4, 5, and so on, the decimal point will always move to the right as per the number of powers that we have, that is the power of 10. Now, when dividing, let's see, when dividing a decimal by 10, and 10 is simply the same as saying 10 to the power of 1. If this is the case, then the decimal point moves 1 place to the left. Decimal place moves 1 place to the left. What are we trying to say there? To illustrate this here, let us take the number that we have, 23.758 divided by 10. 10 power 1 is just 10. So we are saying if this is the case, the decimal point will move to the left one step. So in this particular case, this decimal place will move here, and you'll have 2.3758 as our answer. What if we are dividing by a larger number, maybe 1,000? So I want to say this. When dividing by 1,000, then it is 10 to the power of 3. Then the decimal point will move to 3 places to the left. When we are dividing by 10,000, that is 10 to the power of 4. The decimal point will move 4 places to the left. So let me illustrate this one now without using the table, but with the figures. Now let us look at an example here, multiplying by the power of 10, and the question says evaluate. So we are to evaluate here, and what we are evaluating in this case is 36.532. 36.532 multiplied by 100. That's 6.52 multiplied by 100. So the case here, what happens? As we saw earlier on in our table, we said when you are multiplying a decimal by the power of 10, then the decimal point moves to the right by the number of the power of 10. In this particular case, the power of 10 is 2. That makes it 100. So for this case, to solve this, we shall have 36.532 multiplied by 10 by 100. Then it means that the decimal place point will move twice. So you'll find that this one, the answer here will be 3653. That is 3,653.2. And how did we arrive there? Here it is because of the following. One, we needed to know that the decimal point, because it's 100, will move one step, and then second step, that is where it will stop. So that is where we shall have our value. And we find that 100 has got 2 zeros, which implies that the decimal point will appear to move to the right 2 places. When you have 2 zeros for 100, it will move 2 steps to the right. So that's what we have. You should be able to notice that at 36.532, we have moved to the right 2 steps. So this one is our answer. Let us look at another question. Again, on the same, we evaluate 4.31. Evaluate 4.31. 4.31 multiplied by 10,000. We are multiplying by 10,000. Here, we look at the number of zeros that 10,000 has. It is going to dictate how many steps we are going to move, either to the left or to the right. But because we are multiplying, it is definitely to the right. So in this particular case here, we shall find that for this case, what we need to consider is how many steps are we going to move to the right. Because we have 4 zeros, so we expect to move the decimal point 4 places. And if it is 4 places, that simply means that from the 404.31, we move 4 places, that is to the right. This is the first place for 10. If it is 100, the second place, the third place, and the fourth place. You realize where we don't have digits, we shall put a 0. As long as we get 4, so we have 1, 2, 3, 4. That means that our answer for this particular case will be 43,100. 43,100. We have been able to move 4 steps because of the 10,000. So let us see what would happen if this time round we are dividing by powers of 10. Dividing by powers of 10. Question, evaluate. What we are evaluating here is 268.15 divided by 10, and B, we have 7.82 divided by 1,000. Now, as we saw earlier on in our work, we realized that while we are dividing, the decimal point moves to the left. As per the number of zeros, the number that is power of 10 is. If it is 1 0, it will move 1 step. If it is 2 zeros, it will move 2 steps. For this case, it is 10 divided by, it's simply a number, decimal divided by 10. 10 is 10 to the power of 1, which means that 10 is simply a 10 raised to power 1. So we expect to move the decimal point 1 step. So for this particular case here, then it will mean that 268.15, when we move it, when we divide it, we find that we shall be required to move 268.15. We shall be required to move the decimal place to the left because we are dividing, and it's 10, so it's 1 step, only 1 step. If we move 1 step, you'll settle at 26.815. Therefore, our answer will be 26.815 as our answer, having multiplied by 10, and when you multiply by 10, the decimal point moves to the left 1 step, and that is what we get. For the second question, we have 7.8382 divided by 1,000. Again, we ask ourselves in our solution, how many steps do we expect the decimal point to move? The decimal point here to move, it is the number of zeros that we have. The number of zeros here are 3, or power of 10 is 3, so it will move to the left 3 times. So 7.82 divided by 1,000, I expect us to say that the decimal point will move to the left 3 places. 3 places. If it is going to move to the left 3 places, then if we have 7.82, then we shall move the first step, so 0.7. The second step, we don't have, we put a 0. We need 3 places. The third step, we put a 0, and then we put a decimal point there. So that you find that your answer now this time settles to be 0.00782. 0.00782. 0, 0, 7, 8, 2. You've realized that it has happened this way because when we are dividing, the number of zeros dictates the steps that a decimal point will move to the left. When we are multiplying, the number of zeros dictates the number of steps we shall move to the right. Now let us look at working with missing decimals, some numbers that don't have decimals, but while we operate them, decimals will be generated. Working with missing decimal. Question here, evaluate. And evaluate, our A here is 567 multiplied by 10,000 multiplied by 10,000, and our B is 23 divided by 1,000. Now here you realize that we do not have decimal in any of the numbers that we have. But the rule applies. When you have a whole number, it is always assumed that after the whole number, it is like it's a point that follows. Like if we have, just to illustrate before we start, if we have a number like 6, 6 is the same as, it is equivalent to what we call 6.0. So what I'm trying to say, if you have a whole number, then a decimal point is presumed to be immediately after the last digit, which means that for our first number, 567, it means this is 567.0. So the decimal point comes after 7. Then the rule now applies. We want to solve this. How do we approach it? How many decimal places are we going to move and to which direction? This is a whole number, a decimal point taken to be after the digit number 7. So we are multiplying by 10,000. It means that the decimal point should move, it must move 4 steps to the right. So from this solution, we have 567 multiplied by 10,000. This one will mean that it is 567. Now, the decimal point is here. Whenever we move and we don't have a number, we put a 0. That's 1. Then we move. That is 2. Then we move. That is 3. We need to move how many? 1, 2, 3, 4. 1, 2, 3, and then 4. So what are we getting? We shall find that this will give us 567, and we have 4 zeros, which is 5,670,000. 5,670,000. So you'll notice that we have been able to apply the knowledge of moving the decimal as much as we didn't have a decimal point clearly seen here. How about when we are dividing? Let's see when we are dividing. 23 divided by 1,000. As I've said earlier on, a whole number means the decimal place comes after the last digit. So there is a decimal point after 23. So if there is a decimal point after 23, when you are dividing 23 divided by 1,000, then it will mean that we shall start to count the decimal point from here. And we are going to the left because we are dividing, and how many times? 3 times. So the first time here, second time here, third time here, we don't have anything, we put the 0. So there we are. We have our final answer as 0.023. 0.023. Take note that other zeros ahead of after the last digit are just insignificant, unless we are talking of the whole numbers. But for the decimal part, the number that comes after the last digit is insignificant. So let us now bring in what we learned earlier on about the order of operations. So we are going to operate on decimal, but putting in mind the order of operations and how it is normally worked on. evaluating using the order of operation. Now let us take this question down. Calculate this expression. Calculate this operation using the order of operation. And the question reads 426 divided by 10 into 0.43 times 10. Minus 1.6. That is what we have here. 426 divided by 10 inside the bracket for 0.43 times 10 minus 1.6. Earlier on in our previous lesson, we said when we have such thing, we deal with the brackets first. When we are through the bracket first, then we go into the order of division or multiplication. Then we go for addition and subtraction. It's very important. So for this particular case, as we solve this, we find that we need to work out what is inside the bracket. You need to work out what is inside the bracket. So we shall maintain 426 divided by 10, but inside the bracket, what we have should be resolved. And what we have inside the bracket, we have two areas, a multiplication and a minus. So the order says the multiplication and the division is handled first. Then the addition and subtraction follows, which means we shall have to handle the first part first. That is 0.43 multiplied by 10. If you take 0.43 times 10, it is 4.3. It will mean that the decimal point will move one step. Then minus 1.6. We are still inside the bracket. We haven't finished. We can't open the bracket before we solve that. So we work out the ordinary way, the way we normally subtract the decimal points. Maybe to illustrate from here using a different pen. When we have a 4.3 minus a 1.6, as we said earlier on in our previous lesson, we said when you want to subtract a smaller digit, to a larger digit from a smaller digit, we shall be required to borrow. So we shall borrow 1 here. What remains here is 3. So this one becomes 13. 13 minus 6 is 7. We don't have 4 here. Instead, we have 3. So 3 minus 1 is 2. The decimal point is always maintained. So 2.7, it means that inside this bracket, the resultant evaluation of what is inside the bracket is 2.7. So we can rewrite it and say this is equivalent to 426 divided by 10 and into bracket 2.7. We need to remove the brackets. And to remove these brackets, it simply means multiplication. So we shall come and say this is the same as 426 divided by 10 times 22.7. Which is 426 divided by, this one gives us 27. 426 divided by 27. So you can solve this using a calculator. You can divide using the long method if you don't have a calculator. But when you divide 426 divided by 27, you will get 31.26. 31.26. So the answer is not important. What is important is how we arrived at the method by observing the rule of order of operations. Let us look at application question and see how it works. A service station charges it charges 1.47 How much will it cost? In a service station charges $1.47 per liter of petrol. So 1 liter goes at 1.47. How much will it cost Tanasha to fill her car with 100 liters of petrol? So the first thing we need to ask ourselves, how much is it per liter? And how much does the car consume? So in our solution here, we find how much is it per liter. So the total consumption, the total cost will be the cost per liter multiplied out times the capacity of fuel tank. And when you work out on that, you'll find that the cost per liter is simply for $1.47 multiplied by the capacity, which is 100. As we said earlier on, the decimal point will move to the right 2 steps, so the answer here becomes $147. $147. So application on decimals can be used in any circumstance. Let us now look at multiplying by a decimal. We are multiplying by a decimal. Now, before we move ahead, in our ordinary measurements, you can measure a room measures maybe 2.5 meters or 2.5 meters, 3.2 meters. So decimals exist. If you want to find the area of a rectangular block or a rectangular shape with a length maybe 5.2 and the width is maybe 4.7, we have decimals. We need to multiply decimals. Let us first ask ourselves, when you multiply with a decimal, what normally happens? Let us take, for example, 15 multiplied by 0.5. Just what do you think will be the answer? Is it 15? Is it greater than 15? Or is it less than 15? So in fractions, in decimals, when you're multiplying, always it's good to estimate your answer. And then you'll always try to relate your answer if it's closer to your estimates or it's extreme. If it is closer, then you're doing well. If it is extreme, it means there's a problem. You realize that when we know very well, when you multiply 15 by a whole number, which is just 15, which is 1, we shall get 15. If you multiply 15 by a fraction, then it means it has to reduce. But if you multiply it by 1, which is a whole, it remains the same. So, what am I trying to say here? Everyday lives we go through the decimals, and as we multiply the decimals, we need to observe the following rules. 1. When multiplying decimals, start by ignoring any decimal point and perform the multiplication. Oh. Sounds interesting. When multiplying decimals, start by, I'll use the word is ignoring the number of decimals, decimal places. You start by ignoring the decimal places, and when you ignore the decimal places, you go ahead and perform the multiplication with normalcy. You don't need to go into the details about the fractions. And then on arriving on your answer, now you place the decimal in its correct place. On arriving on an answer, then you place the decimal in its correct place. We shall be looking at it in the next example. Next step that we need to be confident about is that the correct position of the decimal point. The correct position of the decimal point in the answer is found by following the rule that is the total number of decimal places in the question is equal to the number of decimal places. What are we trying to say here? We are saying here that if we want to find the correct position of a decimal point, then it will mean that we first find the total number of the decimal places in the question, and then we go ahead and count how many they are. That is what is going to give us the position of the new decimal place. So let us look for example here. 5.34 multiplied by 1.2. These are decimals. We want to multiply them out. But the rule number 1 says in our multiplication, we forget about the decimals and deal with the number as it is, as if it's a whole number. So we shall have 534 multiplied by 12. So when you multiply this, there are many ways of multiplying the decimals, but in a few cases we have it is 4 times 1, which is 4, 3 times 1, which is 3, and this one is 5. 2 times this one is 8, this one is giving us 6. We got another thing, this one is giving us 10. So when you add these, that is 8, 10, 4, and 6. Do we have a decimal point here? You'll find that we don't. Therefore, we have, okay, as you are seeing, we have multiplied the digits here without putting in place the decimal points. So we have assumed the decimal points, but does not mean we shall leave them out. We shall bring them later on. So we have only ignored so that we can be able to do the multiplication. Then the question that comes, we already have the answer, but is this one the correct answer really? From the point we saw earlier on, it's not, because we say that you only ignore the decimal places, and then having finished multiplying, the number of decimal places will be the total number of places in the question. The total number of decimal places that we have is 1, 2, and 3. So we expect to have an answer with a 3 decimal place. From this one here, we start counting from the last part. This is 1 decimal place, this is 2 decimal places, and 3 decimal places. So you'll find that when you multiply 5.34 by 1.2, your answer will become 6.408. 6.408. We ignore the decimal places. we multiplied, we brought back by asking ourselves how many decimal places do we require, and there we are. Point to note number 3. It is always worthwhile to estimate your answer. Estimate your answer. So it is always worthwhile to estimate your answer. Now, the question now comes here. What are we trying to say here? Because if we are going to estimate the answer, that is not the correct answer. It's just an estimation. It means that your answer should not be very far from the right estimation. Taking, for example, what we had initially, it was 5.34 multiplied by 1.2. If we choose to estimate this one, we shall simply estimate it as approximately 5 multiplied by 1. So because this is 5.3, so we have it around 6. So your answer should not be very far from 5. This is approximately 5. Your answer should not be very far from 5. But our exact answer is 6.408. So it's still close. So we need to estimate our answer first, and then we relate to actual working. Point to note again is that when multiplying by multiples of 10, initially ignore the zeros. After ignoring the zeros in the multiplier, then any decimal point that we have, we ignore the zeros in the multiplier, and any decimal point we have here, perform routine multiplication. Now this one is interesting. You want to multiply a decimal with the power of 10 or a multiple of 10. When you talk of a multiple of 10, it's simply a number which can divide 10 without the remainder. So we can have 5.31 multiplied by a number like 40. 40 is a multiple of 10. So we are saying, ignore this. But put in mind there is that one. Then you multiply here by 4. When you multiply everything here by 4, this is 4, this is 12, carry 1, this is 20, 21, and then you bring in a 0 once. Pop. And then you ask yourself how many decimal places? This is 1, this is 2. You count 1, 2, put the decimal place. What have we tried to say? You ignore the 0 first, do the operation, and then bring in the 0. It's a multiple. If it was 1, 0, move to the left. How many times? The number of decimals, 1. So the issue of ignoring a 0 when it's a multiple of 10 will only be considered when you have finished working the other part, until you have your answer. Like if you are working here, you found it ended maybe somewhere. There, we had 2 decimal places. So it ended there. But then, we have a multiple of 10. So it's 1 0 which was left out. So we shall move the decimal place 1 on the right so that we arrive here. So our answer becomes 212.4. That is how we approach that. So let us look at worked out examples of similar questions. Now, question on multiplying decimals. Calculate 12.31 times 7. Calculate 12.31 times 7, and B, 3.63 multiplied by 6.9. 3.63 multiplied by 6.9. Now, starting from the first one, the rule said very clearly, yes, we have the decimal places, but for us to do the operation, ignore the decimal places, do the operation, then bring in the decimal places, count the total, and put a decimal place. So, when we are multiplying 12.31 times 7, this is the same as 1231 multiplied by 7. What have we done here? Ignore decimal places. We are ignoring decimal places. Having ignored it, then we multiply. 1 by 7 is 7. This one gives us 21. 21 carry 2. 2 times 7 is 14. 14 plus 2 is 16. Carry 1. 7 times 1 is 7. Plus 1 is 8. So we have 86, 17. 86, 17 when we have ignored the decimal places. Then now we come and ask, what is the total number of decimal places in this particular question? You find this one is a 2 decimal place number. So we come here, from the last digit we count, this is 1, this is 2. We have the decimal place there. So our answer is 86.17. That is the answer that we have, 86.17. So you'll notice that here we performed the multiplication by ignoring the decimal place. We realized that there were 2 decimal places that we had, which we put in our mind, so that when we finish the answer, we shall count 2 decimal places. Now, as I said earlier on, that it is always good to estimate your answer. We estimate such that at least you say, my answer should be approximately here. If we are to approximate this one, we would have taken, now I'm looking at approximate value. This one would be, well, let us forget the decimal place, it would be the same as 12 multiplied by 7. When you multiply this, you get 84. It's not far from the answer we have. The answer is 86.17. The other estimation is simply 84. So we are closer to the answer, so we believe the answer we have is the best answer. Second problem that we have, this time, let us start from the other way around. We estimate first, and then we start working out. The question is 3.63 times 6.9 times 6.9. We estimate, and when you estimate, this one is above 5. So this is the same as 4 multiplied by 7, which is 28. So our answer should be ranging around there. I've rounded off. When you look at round off, the digit next is above 5, so we bring 1 this side and also the other one. Now, the actual working here is 6.3, that is 363 times 69, and then here we are saying ignore decimal places. Ignore decimal places. So when you multiply this, you can use any method as you do the multiplication. You'll find that when you multiply this, what you get is, you can use your calculator and you'll get 25,047. Then now it comes, how many decimal places were there? Decimal places were 1, 2, and 3. So there are supposed to be 3 decimal places. So we start counting from the last one, 1, 2, 3, and put a point. So the answer becomes 25.047 as our answer. So we have been able to first ignore the decimal place, and having ignored it, we just moved ahead and we have the decimal, our decimal now put back. Here, same issue, we ignored the decimal places, we performed the operation, we estimated, you see we have 25 5. And then our estimate on the higher side was 28. So it should not be more than 28. So let us look at multiplying decimals by multiples of 10. So this time around is multiplying decimals by multiples of 10. By multiples of 10. So when you work out on that, then the question can be like this. Calculate A, we have 2.65 multiplied by 40,000, and B, we have 0.032 multiplied by 600. Now both the two here are multiples of 10. Both the two are multiples of 10. As we saw earlier on, we say that when we are multiplying by multiples of 10, we assume the zeros. But put in mind the zeros exist. The zeros represent the power of 10. We assume the zeros and perform the operations. So here there are 4 zeros. So we shall come and do that later on. But now we concentrate at 265. We assume the decimal point multiplied by 4. It's an ordinary simple mathematics. When you multiply this, you get 1060. Then the next thing is, how many decimal places are there? There are 2 decimal places. So we count 1, 2. So we are having 10.60. But how many zeros are we putting in mind? 4. So this is the same as multiplied by 10 raised to power 4. Which means from 1060, a decimal point will move 4 times. This is 1, this is 2, this is 3, this is 4. And the other becomes 1060 with the more. We have 1, 2, 3, 4. This is 1, 2, 3, 4. So you'll find that our answer stops at 106,000. What has happened here? For the decimal places, there was no issue, but the zeros we had kept aside are the ones to guide us here. And when you have the number now, because it is a multiple of 10, we shall move the decimal point to the right. The number of places, if there are 4 zeros, it is 4 times. That's how we arrive at this particular question. For this other one again, we have got 0.032 times 600. Again, as we say, assume the zeros, ignore the decimal places. Let us have the decimal places. It is 3 decimal places, and we have assumed 2 zeros. Then from here, we work out the operation. This is the same as 32 multiplied by 6. This is 12, 18. 18 plus 1 is 19. Having arrived at 19, you ask yourself, how many decimal places do we have? There are 1, 2, 3. So from here we count 1, 2, 3, put a decimal point. So you are having 0.192. But we had some zeros taken care of, which is for 100. So we have 2 zeros. So this is the same as multiplied by 10 power 2 or multiplied by 100. So this one means that the 0 moves on the right. It's going to move on the right. How many decimal points? The decimal point moves here, 1, 2, because it's 100, then it becomes 19.2. So the 19.2 in this particular case is the value of the decimal that we were multiplying. It's the value of the decimal we are multiplying. So we can multiply decimals with multiples of 10. So generally, from what we have seen today, you realize that you should be able to handle any decimal without a problem, as long as that decimals meets the areas we have elaborated clearly on in this particular lesson. So anytime you are multiplying the decimals, you should make sure that you are able to identify whether you are multiplying or you are dividing. And as we have seen, when you multiply by a multiple of 10 or the power of 10, then the decimal point moves to the right. And when you are dividing, then the decimal point moves to the left. Let us look at just one more as we wind up. So we have workouts. We want to work out this. 0.003 multiplied by 3. So the weight of the question is not interesting. What is interesting here is how we shall treat the decimal places. So as we have said, we first ignore decimal places. Ignore decimals, which means you shall have 3 multiplied by 3. Put in mind the decimal places were 3 decimal places. So when you get your answer as 9, it is not the answer unless we know where the decimal places are. And now from 9, the decimal places here will come in because 9 is a whole. From here we count backwards. That is 1, 2, and 3. So you find your answer is 0.003. Sorry, 00. You have 9. And this is correct. It is actually 3 decimal places the way we had. So we conclude by saying, when multiplying decimals, the number of decimal places is given by the total number of decimals in the question that we are doing. I hope you've enjoyed the lesson. Thank you.